Hi class. Today we're going to start talking about the analysis of consumer demand, or comparative statics. That means we're going to be changing one thing at a time in our model and seeing what happens to quantity demanded or demand by consumers. So we're going to start with income. And remember, that we always start with our budget line. The quantity of other goods is equal to income divided by PO minus PF over PO QF. Or the quantity of other goods equals the y-intercept minus the slope times the quantity of food. We can plot a budget line knowing that y over PO is the y-intercept and income over the price of food is the x-intercept. Whoops. Two points. Plot a line. We can add a particular set of consumer preferences, and we know that the point of tangency of the indifference curve and the budget line represents equilibrium, where this consumer will demand QF1 quantity of food and QO1 quantity of other goods. When we're analyzing income effects, we look at what happens when we change income. Either we increase income or we decrease income. As we did in previous classes, we know that if we increase income, the y-intercept will increase because y over PO is a bigger number. The slope of the line will not change because income is not part of the slope. And the x-intercept will increase because more income divided by the same price will allow you to purchase more goods. So when income increases, our budget line shifts parallel and out to the right. Along the same lines, if income decreased, the y-intercept would go down. The slope would stay the same. The x-intercept would go down, and you would see a shift inward of the budget line. So the shift outward is an increase in income. The shift inward is a decrease in income. Now, to find out what happens to the quantity of food and other goods that a consumer would demand as income changes, we have to have a series of indifference curves, because it's consumer preferences given their constraints that tells us what they demand. So we know there is an infinite number of indifference curves, all that don't cross. If this is indifference curve or utility representing number 1, and here's utility 2, the same set of preferences, we can see that this consumer, given increased income, would demand more of good 1 or good other goods and more food. In this case, both the quantity of food and the quantity of other goods are normal in economic terms. Indeed, a normal good says that if the demand for a good increases as income increases, prices and preferences held constant, then the good is called normal. Along the same lines, if the demand for a good decreases as income decreases, prices and preferences held constant, then the good is called a normal good as well. If income increases and demand increases, normal. If income decreases and demand decreases, normal. Now there's something interesting about changes in income and consumer demand that's not so easy to draw, but we can try. So here we had our same old budget line. And a given amount of income. Y-intercept, X-intercept, and some given preferences. You know that indifference curves have a different slope at each point because it is a curve. It is tangent at only one point to that straight line. Budget line. So, is there somehow that we can look at a good when income increases and preferences are such that, oh, not doing very good. One good would find itself increasing as income increased, and the other good would find itself decreasing as income increased. Food, in this case, given preferences, would be normal, and other goods would be inferior. If the demand for a good decreases as income increases and increases when income decreases, prices and preferences held constant, the good is called an inferior good. There is an additional concept that we can look at. And note, I am changing what we're plotting to just being food and income. And we're going to get an angle curve. An angle curve describes what happens when the quantity of food or the good on the x-axis increases or changes as income changes. And we can derive an angle curve from our preference map. Income level number 1, income increased to number 2, income increased to number 3. Income 1, 2, and 3. 1 represents a lower income, income 1. 2 represents a medium income, income 2. 3 represents a higher income, income 3. Given a set of preferences where we're going to find the point of tangency between that indifference curve and the budget line, I have demand for food at income 1, demand for food at income 2, and demand for food at income 3. And I can take these demands down, following down, finding a point at income 1, the point at income 2, and the point at income 3. Connect those lines and get an angle curve. Angle curves are related to yet another concept, which is called income elasticity. Income elasticity, in its simplest sense, says what happens when income increases by 1% to the demand for a good, Or what happens to the demand for a good when income changes by 1%. So we can increase income or we can decrease income, and we can look at the change in a quantity. In class, I'm going to do some geometry with graphs, but now let's just look in terms of algebra and actually just calculate. So really what we're looking at is a change in the quantity, and we'll say food, given a change in income, and we multiply that by income over the quantity of food. To have a change, we have to have two quantities and two incomes. So we'll say we're going to subtract the quantity at time period 2 in time period 1 from the quantity in time period 2, and look at income in time period 2 minus income in time period 2, again multiplied by income over the quantity of food. This can be represented in three different ways. We can have what's called a point elasticity using original incomes and quantities. We can have a point elasticity using new incomes and quantities. And we can have what's called an arc elasticity, where we add the two incomes and we add the two quantities. So we can either put this in the equation, this in the equation, or this in the equation. So let's actually see whether or not we can use real numbers and calculate an income elasticity of demand. Well, we know we have to have two incomes, and we know we have to have two quantities. And it's really as simple as that. So let's say this consumer's income increases from 100 to 120. And let's just say we're doing food, and they purchase, I don't know, let's say 20 units of food at an income of $100 and 25 at an income of 120. Let's go back to our equation. And let's do point elasticity at the original incomes and quantities. Oh, sorry. So we have 25 minus 20, or the new quantity 2 minus the original quantity 1, over the difference in income, the new income minus the old income, and a point elasticity at the original incomes and quantity. So we have 5 over 20 times 100 over 20. I can do that. 5 over 20 is 1 over 4 times 10 over 2. I get 10 over 8, or 1.25. In this case, the income elasticity of demand is 1.25. Well, what does that mean in economic terms? First, we know that it's positive. That's a plus 1.25. So in this case, food is normal. We also know this elasticity is greater than 1, positive 1.25. It also means it's elastic. So this says a 1% increase in income will lead to a 1.25% increase in the quantity